Now we are going to look at speed time graph. This is the most important portion of this chapter. First, you need to recall that the gradient of a speed time graph is your acceleration. The y-axis have your speed and the area under the graph is the distance. Let's take a look at this graph. Can you see that the object is stationary? So it gives us a velocity, or also known as speed, that is equals to 0, and there is no area under the graph. So a horizontal line tells us that it is at rest. Changing the position of the object when it's at rest to say 10 meters in front will not change your graph, because as long as you're at rest, you are not moving, so it will always be on the horizontal line. Next, I would like us to look at the graph for constant speed. If you are moving at 10 meters per second, at 0 second you are 10 meters per second and you are constant throughout, so this is a constant speed. I want you to compare the two gradients. Can you see that both gradients are horizontal lines? And what is gradient implying? Gradient let us calculate our acceleration. Since both of them are horizontal, it means that acceleration equals to 0. Now that makes sense. Regardless of whether you are at rest or moving at constant speed, your speed do not change. And acceleration imply either increasing or deceleration, which imply decreasing speed. Next up, I would like us to look at our constant acceleration and constant deceleration. As the graph shows, a straight line means it's a constant, and in this case it's going up, so anything flying in this direction implies that it's speeding up, so it's a constant acceleration. Anything that's going down this direction is slowing down, so it is a deceleration. And since it's a straight line, so it must be a constant deceleration. Finally, let's take a look at this. Can you see that in this case, both the graph are flying from the bottom left to the top right? So this implies that both graphs are acceleration. But as you look at the gradient go from steep to gentle. So this is a decreasing acceleration. On the other hand, over here is from gentle to steep, so this has to be an increasing acceleration. One common misconception that students have regarding decreasing acceleration is that they thought that it is slowing down, which is not true. It simply means that my speed increases at a slower and slower pace. Next, I would like you to take a look at this example in your notes. Can you see that this is a velocity time graph? So straight line implies constant acceleration, horizontal line implies constant speed, and negative straight line going down implies constant deceleration. And wherever we describe all this motion, please make sure that you put in all possible values. In this case, how do I get 1.5 meter per second? I look for the gradient. Can you see that this is 30, this is 20? So the gradient is the vertical divided by the horizontal difference. So it is 30 divided by 20. I get 1.5 meter per second. Constant speed, you read off, it is horizontal line of 30. So this has to be a constant speed of 30 meters per second. Finally, in this case, because I put down it as constant deceleration, after you work out your acceleration formula is a negative value, please remove your negative sign because it is replaced by the word deceleration. Now there are times where instead of looking at acceleration, we would like to find out the instantaneous speed of a motion at a specific timing. In this case, they are asking you at 2 seconds, what is my speed? So 2 seconds is here, you move up, you read horizontally, it is 40 meter per second. At 0.5 second, where is it? Well, 0.5 is somewhere between 0 and 1. You move up, you move horizontally, it's estimated at around 22. Now for those of you who do not like to use y2 minus y1 divided by x2 minus x1, you can also make use of the formula a equals to v minus u over t to work out your acceleration from the graph. So let's take a look at this graph. Can you see that over here you start with 0? So this is u is 0 meter per second. You end at 40. So v is 40 meter per second, and between the two velocity, it is 4 seconds away. So you just apply this into your a equals to v minus u over t. You can get your answer in the same manner as your gradient formula from mathematics. Finally, we look at how to find distance from a speed-time graph. It is from the area under the graph. We're going to derive this for you using your very well-known formula where speed equals to distance over time. So distance is speed times time. Now, if your speed is 20 meters per second and it takes place for 5 seconds, using this formula you will have gotten 100 meters as the distance moved. Now, if we plot this as a speed time graph, can you see that since this is moving at a constant speed, so it must be a horizontal line, and our 100 meter is actually the area under the graph. What do we mean? It means it must be between your line and the x-axis. Now, please take note that when you want to calculate distance, as long as the motion is not constant speed, you've got to plot your speed time graph and find the area under the graph. Do not ever use this formula unless your speed is constant. So in summary, distance in speed time graph can be found under the area of the graph, speed from y-axis, and acceleration from your gradient. Thank you. This is the end of speed time graph.